All right, class, this is part 2 or part B of the Spring 2025 final review for advanced or Algebra 2P. All right, we got through question 3 and we're going to pick it up at question 4. 4 is pretty straightforward. They ask you to describe the transformations of the rational function from the parent function y equals 1 over x. Well, you will say that y is shifted left 2 units, and that came from this, right? Your x's are liars. It's also shifted up 9 units, and that came from this. And it's also, you got to pay attention to this. That is not a 1. It was a 1 over here, but it's a 5. So we'll have to say it is stretched by a factor of 5. Okay? And that's it. Question 5 is actually they're going to ask you to identify vertical asymptotes, horizontal asymptotes. Vertical asymptotes, horizontal asymptotes. They'll ask you for the domain and the range. Okay? The vertical asymptote is just whatever makes the denominator equal to 0 here. So that's going to be at simply x equals 8. Okay? The horizontal, when it's written in this form, is going to be whatever that number is. And we write it as an equation. Y equals -5. The domain, I'm sorry, I shrank it together, so the domain D will be all real numbers except x cannot equal 8 because it makes the graph go bad. The range is going to be all real numbers except y cannot equal -5 because it's the horizontal asymptote. So putting that all together, knowing that there's a vertical asymptote at x equals 8, 1, 2, 3, 4, 5, 6, 7, 8, so it's right here. Okay, and I'm going to change that to be dashed. Okay, also the horizontal asymptote's at -5, 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5. It didn't go straight. Sorry about that. Oh, come on. See, it has all these issues. There's something wrong with the screen. Anyway, let me just put it back down here. I'll just draw my own. It's taking too long to... Okay, so we have this. Now, the graph will, as it approaches this vertical asymptote, the graph has to bend. Either it's going to bend up like this, so it'll be something like that, or it's going to bend down like this. All right, so what you want to do to find the graph, you want to choose one point to the right, and I'll put that here in orange, some point over here at 9, see where the graph is, and then just have the graph pass through the value that you found. So if I put 9 in, then y would equal 1 over 9 minus 8, which is 1, minus 5, which is -4. So we know at 8, we're at 1, 2, 3, 4. So we're here. All right. So the graph is going to go off like that, and it's going to go up like that. Okay. Likewise, choose one point to the left, but you're pretty sure notice this one's above the horizontal asymptote. The one to the left will be below. But just to verify, let's choose a number to the left of the vertical asymptote. So at 7, So y equals 1 over 7 minus 8 minus 5. That's negative 1 minus 5, which is negative 6. So that puts you right there. So you know this graph to the left, I'll use green now, is going to bend and do that. And it's also going to keep going to the left. So there's the graph. All right, pretty straightforward. Okay. Notice the range is all x values except at 8, where the vertical asymptote is, and the range is all y values except where the horizontal asymptote is, where the graph bends. All right. Now, on 6, they want you just to identify the following features of the rational functions. Okay, to do this, you want to do the F word, factor. So you got x squared minus 6x minus 16. I'll just go ahead and write it in factored form. You should know that what multiplies to negative 16 and adds up to negative 6 is x minus negative 8 and positive 2. Okay. What multiplies, I'm looking at the bottom now, what multiplies to 8 adds up to 6? Well, I believe that's x plus 4, x plus 2. Notice the x plus 2 divides out. That is what gives us a whole, by the way. And we are left with this, x minus 8 over x plus 4. So the x-intercepts is whatever makes the top equal to 0. So what makes x minus 8 equal to 0? That's going to be x equals 8. The vertical asymptotes is when the bottom equals 0, and that's going to be what makes x plus 4 equal to 0, and that's x equals negative 4. And the whole was from the term that was divided out, the x plus 2. So it basically is the number that makes the top and bottom both go to 0, and that's going to be x equals negative 2. Now, I'll clue you in. I'd like you to write this as an ordered pair. All right? For the last quiz, we only wrote where it was. To find the actual y value, plug this number in to this after we divide out the x plus 2 that gave us the whole. What you are doing is actually a little calculus, or a little, you're doing limit theory a little bit. Not that you need to know that. So the value is going to be y equals negative 2 minus 8 over negative 2 plus 4. So that equals negative 10 over 2. And the y value of the whole is negative 5. So you would say the whole is at the order pair negative 2 comma negative 5. Okay, but I want you to find the y value. And again, all you got to do is, after you reduce the fraction, right, and got this, you just got to plug in the x value of the whole, which is x equals negative 2. All right? So, the next one, we'll do a, b, and c. That's 8, and we got 10. So I'll get through 7 and 8, and then I'll stop this video and do the last video. On this case, to add fractions together, you have to find a common denominator. They have to be over the same thing, and as you can see, they are not, right? This one's x plus 1, and this one's 3x minus 3. So to help us figure this out, what we are going to do is factor whatever can be factored, and right here, it's a 3 can be pulled out. So now it's that. And then we look for the LCD. You see x plus 1, you write it. You see a 3 from here, you write that. I'm going to put it in front, and then the x minus 1. So that's the LCD. So what we are going to do is we are going to multiply this LCD across the top on each of these fractions, basically multiply it by 1 and reduce. And then, actually, hang on. It'll be 5. Actually, I'd rather say it this way. Here's the 5. And just go ahead and write the LCD underneath it. This is how I'm going to do it, because there's multiple ways. Okay. So it goes here. Now, notice this was 5 over x plus 1. I have to add to the top the parts that are missing from the original problem. So in other words, a 3 is missing. So I have to make sure I multiply the top by 3. And an x minus 1 is missing from this, right? Got an x plus 1. We don't have that 3, and we don't have that x minus 1. So I add it to the top. So what this is, if you reduced it, would be that. All right, but we're not reducing because it's over the common denominator. Then this is going to be plus 4. I'm going to write this in factored form. Okay, so this is 3x plus 1, x minus 1. Now, what is missing here that is there is x plus 1. So I have to add it to the top. And I'm going to put that in orange. All right. If you looked at each individual fraction and reduced it, you would just end up with what was originally given to us up here. All right. But notice, they are now over a common denominator. So we can now just add across the top. So what do we have to, sorry about that. So what do we have to do? We have to just multiply 5 times 3. And then, so you get 5 times 3 is 15. And then we end up with 15, parentheses x minus 1, plus 4 times x plus 1 is 4x plus 4, all over the LCD of 3x plus 1, x minus 1. Looking at this, distributing the 15 and combining like terms, I'll just go ahead and write it here. So if we distribute the 15, we'd have 15x minus 15. And now combining like terms, you got 15x plus 4x is 19x. Negative 15 plus 4 is negative 11. And we just keep the LCD. And that is the answers for that problem. Okay? You see, it can be very tricky. Here's another one. I gave you 3. So on B, the LCD, you can tell, you just look at the denominators. Can we factor each one of these? No. So they're both linear terms, right? We got an x plus 1 and x minus 1. So the LCD is just going to be the combination of those two. So it'll be x plus 1 times x minus 1. Then we're going to rewrite this as 2x over the LCD of x plus 1, x minus 1. And I'm going to go ahead and change this LCD to be a different color. Let's go style. Let's go purple, I guess, or pink. So this is the LCD, and that's pink. So now, what is missing from the original fraction here? On the bottom, x plus 1, we're missing the x minus 1. So we're going to add that to the top. And if you just look at this and reduce it, you will see that you're left with a 2x over x plus 1, because these would divide out. So it's the original fraction. All we're doing is changing the fractions into equivalent fractions. And this is all over the same LCD. So looking at this one, what's missing? And that is to this, and that's going to be x plus 1. And now it's just a process of distributing and combining like terms. Okay, so you got 2x times x is 2x squared. You have 2x times a negative 1 is negative 2x. You have negative 5x minus 5 from the back end, right? Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. All over the LCD of, let's see if I had saved it. I did, but it's in gray. Oh no, it has a 3 on it. So I'm going to kill that 3. Okay. All over that LCD. Just combine like terms, right? You got 2x squared minus 7x minus 5 all over the LCD. Okay? Without the 3. The last step would be to try to factor. What do I mean? We got to see if we can reduce this. So we're going to look, and this one can be factored. I'm just not sure if it's going to come out with terms that are that can be reduced. But you can find two numbers that multiply to negative 10 add up to negative 7. And that's going to be negative, ooh, hang on. I thought it was going to be 5 and 2, but that's not the case. They have to be different signed, and you can't factor it. Okay, negative, if that was a positive 5, then you could. So this would be your final answer, but I did look to see if it can be factored. Okay. All right, the last one of this is the LCD. Well, this one's fairly straightforward. The LCD, you look at the first fraction, there's an x, so you're just going to put x. You look at the second fraction, there's a 2x. Well, we already have this x, we just are missing the 2, so we add the 2, and that's the LCD. Okay, so the first fraction was x plus 9, and it's going to be minus x minus 8, and it's going to be over this common denominator of 2x. But now, we have to look. What's missing here that's part of the LCD? And you'll say, hey, well, we're missing a 2. And you're right, so we got to put a 2 up in front. What's missing here that's there? And you'll say nothing, so we just leave it. So this works out to be 2x plus 18. And now remember, this is minus x minus 8. I forgot to put the parentheses because it's minus all of this. So you could either do it in your head and go, okay, 2x minus x. So it's going to be this. Basically, it's minus x plus 8. What's hard is I would recommend for you guys when you see subtraction with polynomials, you flip the signs on the inside of the parentheses and just make that a plus. Then you won't screw up the signs. So when you do that, and it's all over, by the way, I kind of skipped that. It's all over 2x. So combining like terms, 2x minus x is x. 18 plus 8 is plus 26, all over 2x. Now, before you get excited and think you can divide out, see, there's an issue with my screen right there. I should be making that mark. Resist that urge. You cannot go 2 and 26 and get 13. This top is holding hands. You cannot just change one piece by dividing one of them by 2. You have to either divide both of them by 2 or leave it. And so we're going to leave it. Okay? I saw that on your quiz, that some students would go 26 over 2 and get 13. Or maybe even go x over x and get rid of this x or something. You can't do this. On top, they're holding hands. Okay? All right. Now, 8 is the last one I'm going to do because my class is going to come in. I'll have to make my third video later. On 8, it's kind of crazy. You guys factor everything. Remember, factoring is the key. So we're going to factor everything. So looking at this top piece, it's a quadratic. What multiplies to 24 adds up to 11? Well, that's going to be 8 and 3. So I'm going to rewrite the top fraction on A as x plus 8, x plus 3. Okay? Again, you can check. 8 times 3 is 24. 8 plus 3 is 11. All right? Then on bottom, well, all you can do is GCF. You can factor out 6x squared. So that's going to be 6x squared. And that's going to leave you with an x plus 3. Okay? Times, do the same thing on the top of this fraction. What can be pulled out? Well, it's 6x squared. And that's going to leave you x plus 1. Okay? And then the bottom is another trinomial. What multiplies to negative 4, adds up to 5. And I believe that's going to be 8 and negative 3. So we would get x plus 8, x minus 3. Now we're going to start dividing what is common. Well, we got an x plus 8 and an x plus 8. We got these two x plus 3s. And we have 6x squared and 6x squared. What's left is the product in reduced form. So you have just the x plus 2 on top. Or 1, 2. What the heck am I thinking? And then on bottom, you'll have the x minus 3. And that is your answer. Right there. Again, it is this term was left and that term was left. And that's why I wrote. Over here on B, factor everything. All right, I'm going to have to stop this after this problem. So m plus 1 on bottom, that's going to be 3m minus 5 times, factor out an 8 here, so that's going to be m minus 10. Then on bottom, what multiplies to negative 10 adds up to negative 9. That's going to be m minus 10. So that will be m minus 10.
Hey, Mr. Nicholson.
M minus 10. I'm recording, so come back in a few minutes. M minus 10 and m plus 1. All right? So now divide out everything that can be divided out. And you're left with just the 1 over 3. 1 over 3 m minus 5. And that's the answer. Okay. That was number 8, but I'm thinking I'm going to have to stop because I got kids coming in. So I will finish 9 and 10 on my next video.